Good afternoon, everybody. Welcome to yet another roundtable on smart asset management organized by World Class Maintenance. My name is Henk Akkermans and I'm your host again today. The topic of today is a very important topic, design for maintenance. Very important, but often overlooked. I think actually, but perhaps my experts today will disagree. Let's introduce those experts. Welcome, everybody.
Okay.
So, Jan, can you please introduce briefly yourself?
Yes.
Of course, your organization, but also while you're at it, give us an example of best or worst practice in design for maintenance, if you may.
Okay. Now, thank you, Henk, for letting me myself introduce. I'm Jan Bergsma. I'm associate professor in the chair of maintenance engineering of the University of Twente, and as such, we are also busy with topics around the design for maintenance. So it's one of our interesting topics we also study and also lecture about. And then, with regard to best and worst practices, I think that you see that a few years ago, people were just not so aware that maintenance should have a role in the start of a new project. But I think what you see is that people are now more consciously aware that this should happen, but not always act accordingly, you could say. So I think that's a kind of change from the past. But if you see what are interesting examples, I think that's, for example, in the Netherlands Railways, the use of Rams LCC to look at reliability, availability, maintainability, and safety, and also life cycle costing characteristics at the start of a project for contracting. So then this is used to start up a kind of negotiation also with the possible companies. And when does it go wrong? If this process if maintenance is not really involved during the process, and I think that's happening a lot, so perhaps it's done in the LCC, Rams LCC requirements, but during the process, most often maintenance is a bit out of scope. And I think then a good practice I've seen and witnessed at, for example, Cytec, also a famous company in the Netherlands doing maintenance, is having being on board at the start of the project, but also during the project, but that the influence becomes less and less after the project matures, and that then the cost associated with a change proposed by people from maintenance becomes higher and higher. So as such, you are sure that design for maintenance is really taken into consideration, but at a certain moment it also stops. And I think there is often the problem with incorporating more and more people for an optimized result is that it never stops. And we as technical people tend to want to have influence. But I think you need to have a kind of right negotiation model for that. So that are a few things I can say for now, Henk.
Okay, thanks. And others, I think we should return later on also to this topic of stop. So when does design stop? Because nowadays does the designing ever stop in our digital era? But let's for now let's move to another expert. And Joost, you're next on my list. Joost Matulesi. Joost, please introduce yourself, your organization, and give us an example of design for maintenance in your area.
Well, I'm Joost Matulesi. I work at Tata Steel Europe, mainland Europe, and my function is to get maintenance into projects, CapEx projects, and for CapEx project that after deliver the asset that maintenance is installed for the maintenance department. The problems we have is that our projects are time and cost based, and thereby maintenance is for project managers irritating to take with it. And so also with negotiating with the contractors, maintenance is mostly lost or is taken with it in a low base, because if they must take the requirements we have with it, it's too difficult. And also what is meant by Mr. Braaksma is that the life cycle costs are mostly forgotten. So after that, the maintenance costs, the yearly costs, are higher than necessary.
So they need you out there, Joost, then to let the voice of maintenance be heard.
Yes.
Because well, let's return to that then in the coming hour. Robert-Jan.
Robert-Jan Bart, employed at the Dutch Ministry of Defense. I'm working at the Center of Excellence for Program of Requirements. That's one branch with a goal to improve program of requirements within the administration of the Dutch defense. Worst and best practice. I think the best practice in MOD is that we have adopted standards such like system lifecycle management, which should ensure lifecycle approach. But the challenge is how to implement that really in the organization, that everyone is aware of that principles within that standards. Another challenge is the EU tender regulations, especially for a project with a large design component, and mostly now it's on a lowest price. Price is a good comparison between projects tenderers, but
that's a purchase price, eh?
Yeah,
that's a purchase price, not maintenance, not life cycle cost.
Exactly. So that is the challenges within the Dutch Ministry of Defense.
Do you see, so on the background we see F-18 fighters. So in aircraft, are there differences between Navy, the Army, and the Air Force, in the sense that those F-18s, you buy them off the shelf, you do not design them as Dutch Air Force, whereas the ships we often do design ourselves. Does that make a difference in how difficult or easy this implementation of design for maintenance is?
It's exactly what you say. Dutch naval ships often are designed by our own bureau within the ministry. There it's possible for us to have some influence on the design. But exactly for the F-18s or the F-35s for Netherlands is quite difficult. You don't have influence on the design because we participate in the project, but the United States is the main contractor for the project. So other countries have to follow what the US decide on that.
Yeah. So then you hope that they have done a good job then. Okay. Roland, also our host, but also someone with considerable industrial experience by now. Could you please introduce yourself, but also some examples of an example of good and best practice from your experience?
Okay, so I'm a lecturer at Tilburg University and did my PhD research at Tata Steel and BP. If I look at a good example, then I go back to one of the things we saw last year with Kroon, Wolter and Dros. If you look at the tunnels in the Netherlands, Then those tunnels, there's a lot of electrical equipment and other equipment in those tunnels. And what they did now over the years is they made sure that you have the driving lanes, and those have to be accessible, but they made an additional lane in between for the maintenance engineers, where they put most of the equipment in a separate tunnel, which is always accessible, and you don't need the driving lanes for that. And they also moved many of the equipment to a little cabin outside of the tunnel with a controlled environment, where it's also much easier to perform the maintenance than in the tunnel itself. So they tried to move pieces of equipment to places that are much better accessible than where it initially was. So you see that in the newer tunnels. Yeah. If I look at BP, then I was present at the design of a new effluent treatment plant there in the beginning, and we followed the making of the maintenance plans. And there you saw that they took a whole year to develop all of the maintenance plans for that. But then the equipment was already designed. You could only play with what maintenance are we going to perform, with what frequencies, but not with the design of the equipment, which was done by an external agency there. So a lot of they didn't have that many degrees of freedom anymore. But yeah, so it's a bit the same with the F-18 and the F-35. You just have these plans, and those are sort of building blocks that you need to work with.
So what we all have is the consequence of digitization, and that more and more of the assets that are built today or that are upgraded today is that how they operate, how they work, changes over the life cycle, because the software changes. This is true, of course, of the F-35 fighters. They all of a sudden could fly better because the software got an upgrade. It's true of my car. It's true, hopefully, of our laptops and mobile equipment. It's also true of the machines of ASML or Van der Lande or some of those high-tech equipment manufacturers. But I think it trickles down everywhere. To what extent does it make design for maintenance easier, because there's always another round in which you can participate, or harder because it never stops? Who has an opinion on that? Jan, yes, please. If you turn the mic.
I think, design for maintenance, in a way, it never stops then, because the product is still developing. So I think physical hardware management goes more to software management because of that. And then you can also look at the practices they have. And then usually you did design for maintenance at the start of a project, and then perhaps for the modifications, and then for a rehaul, and then more or less you could also do design or redesign at the moment you find that you have equipment failing too often or having big problems. But I think indeed with these firmware updates, and you see them everywhere, we have a lot of contacts with Leander. Now there they also have issues with regard to IT and OT and the integration of information technology with their equipment. It's the same for the Netherlands Railways. And I think we are now in a stage that's becoming more and more realized by companies, that this also has to be managed. I think in the past it was just thought that this was something for the suppliers. It was really hidden. And currently it's sometimes still hidden because the physical element you see, you are trained for maintaining that. But the software part becomes more and more important. So then you also have to make plans for configuration management, for the cybersecurity aspects, who to contact with which problems, how to do fault finding or that kind of things. And yeah, that's something which still needs to be organized, but I agree, Henk, that's a trend, that these kind of things become more and more into the current asset management. But I also see it as something which is also still under research a bit, how to do it appropriately. Because what you then also see is that IT departments have to work together with traditional physical asset management departments, and they have been separated from a long time ago already. And so you have now first an integration challenge also there to more or less let these departments communicate better with each other. And because of this, how you say it, the integration issue, it's also more difficult to get them on board at the right moment in time in such projects.
Robert-Jan, how does it work at the Ministry of Defense? Does is this indeed something that works two ways? I mean, makes it harder? What's your experience?
Well, digitization for the Ministry of Defense, we don't want everyone to know where we are, for example, in the battlefield. So you can always connect with the supplier to your equipment because of the challenges of information security. But I think it can be really helpful to have more data and digitization for systems and better lifecycle management.
Well, I understand the security issue, but just from my own outside view on this. There's a naval vessel, and the way that the drivetrain, the engine and so on operates, is largely managed also by software. You get an upgrade by software, and now it's better. It consumes less fuel and it degrades less fast. So that's good. Or the other round here is a fighter plane, and now of course with the other software it can have faster angles, or sharper angles, or higher acceleration. As a result of that, the plane degrades faster, which is, well, great if you want to win the battle, but of course not so great for maintenance. Those things, are they also part of your of the things you look at, of design for maintenance within, or is it just an unintended side effect of the whole thing?
Well, I'm not aware of that it happens. I know that the Joint Strike Fighter is a flying computer, but the details of it I'm not aware of. So.
Okay, of course. Yes, of course, yeah. Joost, at Tata Steel, it's all old stuff, no computers around, or what's the real story?
What I see with projects that the contractors still build traditional, when it is about the hardware. When it's software, then you see there's a connection also in maintenance. For instance, the condition monitoring that is doing better now. So the condition of installations is to monitor the condition by how you call that, trilling in
Vibration.
Vibration, etc. That is going well, but if we want to build new assets, it's very hard to ask contractors to think with us to have an installation with a good design for maintenance. So at the end, we still have installations with with the same need of resources.
Yeah.
And the need of resources, especially with engineering, is worse to get. So that's a big problem now.
Yeah, I think so. That's very frustrating. I think if you look at NS, for instance, Dutch Rail, Jan has some. He probably has the numbers better than I do, but I think every new generation sort of has half the maintenance hours on an annual basis, and so that's what you want, isn't it? That every new generation is not only a better train, complete with toilets, etc., and Wi-Fi and what have you, but it also is easier to maintain. And there indeed, that doesn't happen automatically. Yeah.
Now, when the trains become, for example, more and more complicated, so I'm not so sure if really maintenance is really reduced by every generation, because I think that the number of functionalities on board of these trains is also rising.
Yeah,
like
constant.
Like Wi-Fi signaling. I think the autonomous train driving functions are getting introduced in a way, so that there is a kind of automatic signaling, that kind of stuff also becomes part of the trains. So at the same time as we improve our processes, I think also new technology is introduced, which also gives new challenges. And for example, also with these trains nowadays, you have not anymore the traditional toilet system in which you could just open the train and then say, hey, we have get rid of how do you say it?
Things.
There are things, yes, and then now you need a really sophisticated processing system for that, and that processing system can fail in all kinds of ways. So I think that's a natural habit, I think, of humans to also bring in new innovations when you control the old technologies.
That's of course a trade-off. Software makes it better, but at the same time, software can also lead to new functionality can also.
And then you come into an interesting thing for design for maintenance. I think sometimes probably you could say that some functionalities perhaps shouldn't be introduced from a maintenance point of view, but they are introduced because the manufacturers know that the purchasing departments really like these features as well. So there's a kind of I sometimes have the feeling that sometimes too much functionality is introduced from one generation to another, and that you could have selected what you wanted to introduce. That are difficult questions to answer, but that's what I'm seeing if I see how systems are becoming more and more complex, also of predictive maintenance strategies even, because you put more sensors in it, but the sensors itself can also fail. And when do we know that the sensors have failed? But it remains interesting to challenge that. And I think what's really important here is just in the end cooperation, and to also have some openness with suppliers to work together on these themes. And I think what's happening in reality is that people are just, what I said, aware about it. But at the moment they really have to do these things, then they stop again, because then they go back to the traditional contracts, because that gives them a kind of comfort and security, and individually for the purchasing and procurement department.
Okay, let me stop you there, Jan. Not because it's wrong, it's all correct.
No.
It's part of the next question, I think.
I already go too fast. That's good.
The root causes. But it's clear from this round that this is not a happy topic. This is not one where, it's all going great and we make this great progress. This remains difficult, and even the solutions that we find also have their problems, a two-edged sword, etc. And there are still many problems around there, which is good because that means we can have some improvement. So of good, it is at least, it's the way it is. Now let's look up some root causes, and you already mentioned a few of those.